Good morning. Good morning. You're welcome to our today's class. We are still on the course. Please help me with the matter. Please. Today we'll take a look at chemistry. We are still treating electrolysis. We are still on electrolysis. Electrolysis. So today we'll go over to the laws of electrolysis. Faraday's laws of electrolysis. That's what we'll go over to today. Are we ready for this class? So today we will delve into calculations. Today we'll delve into calculations and see how far we can go. And see how far we can go. Chemistry. Today's debate is what? Thursday, 30th January 2025. So today we go over to laws of electrolysis. Laws of electrolysis. So there are two laws formulated by Michael Faraday, the scientist, the person that formulated this law. His name is Michael Faraday in the year 1834. This law was formulated by Michael Faraday in the year 1834. So there are two laws, the first and what? Second law. So we take it one after the other. We'll take the first law. After stating the first law, we solve calculation there. If there is still time, we move over to the second law. Am I communicating? So I hope you went through what you've done so far in the other lectures. Because soon I'll start asking questions. After asking questions based on what we have done, you have to answer those questions. Yes. So please, let's take whatever we are doing here seriously. Let's do what? Take whatever we are doing here what? Seriously. Are we together? Yes. So let's look at Faraday's first law of electrolysis. Faraday's first law of electrolysis. Okay, so are we together? Are we together?
Yes, sir.
All right. So let's now delve into it. Let's do the first law. Let's go over to the what? The first law. All right. You can put down something. Faraday's first law of electricity. It states that the mass. It states that the mass of a substance. The mass of a substance liberated at the electrode. The mass of a substance liberated at the electrode during electrolysis. The mass of a substance liberated at the electrode during electrolysis is directly proportional to the quantity of electricity. Is directly proportional to the quantity of electricity passing through the electrolytes. It states that the mass of a substance, you can use liberated or discharged. They are talking about the same thing. Am I communicating? You can use liberated or discharged. They are talking about what? The same thing. You can simply say the mass of electricity that pass through the what? Electrolyte. Is it clear? Did you get it? Okay, let me state it again. It states that the mass of a substance liberated or discharged at the electrode during electrolysis is directly proportional to the quantity of electricity passing through the electrolytes. passing through the what? Electrolytes. Is it clear? Huh? Is it clear? Is it clear? Huh?
Yes, sir.
Okay. So if you look up, this is the electrolytes. This now is electrolytic cells, right?
Yes, sir.
The anode, cathode, right? Good. What is inside here is the what? Electrolyte. These two rods are the what? Electrodes. Now, remember I said that when electric current enters here, the ions will start migrating, right? They start migrating. So the Lord is trying to let you know. And you know, let's assume that this one here is this ion, this positive ion is migrating to the cathode. As it's migrating to the cathode, it is either liberated as a gas or deposited on the cathode as a solid, depending on the nature of the water substance. Am I correct? If it's hydrogen that is discharged or oxygen, it goes as what? But metals can deposit here as what? On the surface. Am I communicating? Now, this law is trying to let you know that the mass of this substance that is deposited on this electrode is M. M is the mass. Is directly proportional to the quantity of electricity that enters this what? Electrolyte. Is it clear? That pass through this electrolyte. Remember your direct variation. So what does it mean? It means that as the quantity of electricity that is passing through this is increasing, more mass is what? Or substance is liberated or discharged or deposited. Am I communicating? Is it clear? So as you increase the quantity of electricity, more of the substance will be what? Discharged or deposited at the what? At the what? At the electrode. Is it clear? So from this law, first law, M, there's no matter here. Which kind of matter is this one?
No, very good.
No, this is working. Please let me ask you, this matter is not working. So we going to wrap and forth today. Is that the meaning? Can you see it? So if you can see it, let me continue. How do you now do this now? Today is calculation. Okay, let me see how far we can go with this one. And the mass is directly proportional to what? The quantity of what? Electricity. Is it clear?
Yes.
So what it means is that as the quantity of electricity is increasing, the mass is what? Increasing. Is it clear? The quantity of electricity is increasing, the mass is what? Decreasing. Remember from current, as quantity of electricity is decreases, the mass is what? The mass decreases. Yeah. That's enough. Okay, no problem. That's enough variation. Direct variation now. As just this one is increasing, the other one is what? Increasing. As this one is decreasing, the other one is what? Also what? Decreasing. That's mean of direct what? Variation. If it were to be inverse variation, as this one is increasing, the other one will be what? Decreasing. Opposite. So because it's a direct variation, it's directly proportional. So as the quantity of electricity that passes through the electrolyte is increasing, the mass to be deposited at the electrode will also do what? Increase. Now remember from our current electricity that quantity of electricity is equal to what? Current times time. Remember that you are what? Current what? Electricity. That quantity of electricity is equal to what? Times what? Time. This one is measured in coulomb. Hope remember. Current is in ampere and time is in what? Second. So from here now, if cure is equal to IT, I am proving something. I be putting this in down. I'm trying to derive show you the mathematical representation of what? Of what? Variance law. Please, if you are lost, let me know. I start from here. You can remember that M is what? Mass of what? Of the what? Substance. Clear is what? Quantity of what? Of what? Electricity. Is it clear?
Yes.
So if M is directly proportional to Q, and Q is IT, it then imply that, I follow you. It then imply that M is directly proportional to IT. Do you agree with me?
Yes.
Do you agree with me? Do you agree with me? If mass is directly proportional to what? Q, which is the quantity of what? Electricity. And quantity of electricity Q is equal to IT, current times time. That means anywhere you see Q, you put what? IT. That means M is directly proportional to what? IT. Is it clear? So the mass is directly proportional to the current and the time it takes to pass through it. Is it clear? So this is the Faraday's law. But remember, this thing is just, this here is just what is it called? This here is just an expression expressing the proportionality. It's not an equation. So we need to introduce a constant in order to remove this sign of what? Proportionality, and add a quantity sign. So if you have to add a quantity sign, we introduce a constant. And the constant we introduce here. So what it means that M is not equal to, we put a constant. You can use K, but the one we normally use here is EIT. Are we together? Are we together? Are we together? Are we together? There in some texts. Please, if you are lost, let me know. Please, I beg you. Don't keep quiet. Because if you keep quiet, I'll continue and think that you are with me. So if you are not following, please call my attention so I can explain. Is it clear? So the constant here is E. Look at me what this E is. What is E? What does it present? It's a constant, you know, but it's just a name. You have done electricity in your secondary school, so tell me. You have done electricity in your secondary school. So tell me what E presents. It's a constant here now. But
that's the number, like that's the number, the Faraday's law.
What is E? Which is number? Tell me number. What is number? This thing is your secondary school work.
I forgot to understand 2 years ago.
2 years ago.
Yes, now.
2 years ago. Hey. Oh, wow.
I
am telling you,
I know this story.
Ayo, tell me now. No idea. Eh? No, it's not.
Electricity.
No. Okay, put it down. E here is a constant, and that E is called electrochemical equivalence. It's called what? Electrochemical equivalence of the substance. Electrochemical equivalent of the what? Substance. It's called what? Electrochemical equivalent of the what? Substance. Is it clear? Huh? So E is what? Electrochemical equivalence of the what? Substance. So if that is the case now, according to Faraday's law now, M is equal to what? E what? IT. True of us? True of us? Or it can also be that M is equal to what? E what? Q. True of us? Because Q is what? IT. So this is what Faraday's law states. So let's do what calculation on that. Are you ready? Are you ready for a calculation?
Yes, sir.
Put it down so I can give you a question. Let's solve it and see what we can get. You are asking for calculator. Do they allow you to write down with calculator?
They don't write down with calculator.
Okay, you are not using
I
before.
don't know. I've not written that before. It's calculator system.
You are your system.
Yes.
That's why many of you fail issues in jam. Please don't depend too much on calculator. That is sort of question.
I don't know how to use the computer.
Don't depend too much on calculator. Please, it's very important because you'll be disappointed and you will know what to do. Or I put down this question if you are true.
Example.
Yeah, put down this question. Are we together? Are we together?
Yes, sir.
A current of 2 ampere. A current of 2 ampere. A current of 2 ampere. Yeah, 2 capital letter A. Good. Is passed through. A current of 2 ampere is passed through a solution of copper sulfate. A current of 2 ampere is passed through a solution of copper sulfate for 10 minutes. A current of 2 ampere is passed through a solution of copper sulfate.
Please, can you write the formula? Copper sulfate.
You don't do the formula for
Formula, yes.
you don't know the formula.
Okay, CuSO4.
I know. A current of 2 ampere is passed through a solution of copper sulfate for 10 minutes, full stop. If the electrochemical equivalent of copper, if the electrochemical equivalent of copper is 0.000329, if the electrochemical equivalent of copper is 0.000329 gram per coulomb, comma, what is the mass of copper deposited? A current of 2 ampere is passed through a solution of copper sulfate for 10 minutes, full stop. If the electrochemical equivalent of copper is 0.000329 gram per coulomb, comma, what is the mass of copper deposited? What is the mass of copper deposited? Are we together?
Yes.
Remember that from what we discussed about Faraday's first law, are you following? Are you with me?
Yes.
Remember that what we discussed about Faraday's first law, we concluded after deriving the formula, we concluded that the mass is equal to solution. We concluded that mass is equal to EIT. M is the mass. E is the electrochemical equivalent of copper. In this case now, the substance is what? Copper. M is the mass of copper because the substance in question now is copper sulfate. True of us? True of us? Then I is current. T is what? Time. T is what? Time. T is what? Time. Remember that M is in gram. E is gram per coulomb, the unit. I is ampere. And T, the time is seconds. Even though they gave it to us as what? Minutes. That means we need to convert it to what? Seconds. Is it clear?
Yes.
Alright, so this is the formula. So from the formula, M, we don't know M, right? We put question mark under M. Three of us, we don't know M. We are already given E.
Yes.
What is E?
0.00
what?
329.
329 gram per watt coulomb. We are given current.
Yes.
What is current? 2 ampere.
Time.
We are given time.
Yes.
Time is what?
2 minutes. 10 minutes.
10 minutes. 10 what? Minutes. But we need to convert this 10 minutes to seconds. How do you convert minutes to seconds?
Multiply by 60.
By 6, right? Right? So by 60, we have what? 60 what? 60 what? 600 what? Seconds. Three of us, we have 600 seconds. We have what? 600 seconds. Now, these are the parameters. So let us now put the parameters in the equation and find the value of what? M. Should I continue?
Yes.
So let's put the parameters in this equation. So mass is now equal to what? Mass equivalent is what? 0. What? 329 gram per watt coulomb times the current I. Current is what? 2 ampere times time is what? 600 what? Seconds. So what's the answer? If you thought that calculator, I'll do it with you. What is the answer? Also, fast. Tell me the answer. If I were you, remember, if I were you, I will move this to standard form. Then multiply out, bring back these zeros back and get my answer. Simple. So learn how to work with that calculator. It's very important to learn that, all that. But you are studying that table. Is that your study table?
No, yes.
Okay. Alright, so what's the answer? Let me know that know how to take it with that calculator. Oh yeah. So 2 minutes have gone. You people have not solved this thing. Have you gotten the answer? Yes, sir.
300.
3 what?
394,800.
It's not true. Look up. Let me give you a clue on how to solve question with that calculator. In exam listing tension, as in exam condition, try to move. In fact, let me move this table thing to standard form. Am I completing? If you watch, here there is 0.0003 here. Now, this is taking as saying if you move, are you watching? Move this in like this. 1, 2, 3. 3 minus 1 minus 2 minus 3. We have 329 times 6 power what? Minus 3. Are you there? Because if you go further, minus 4 minus 5 minus 4, it becomes minus 4. But because you stopped here, it becomes minus what? 3. Then times 2 ampere, right? Times 6 times 3 is 4. This is 3 minus 2. Sorry, 2. 1, 2 times h power what? 2 what? Seconds. Ignore these big numbers, multiply this and this and get the answer and bring back those standard form. So if you want to do it, now simply do first do 329 times 2 sharply. 329 times 2 is what? 658. Are you sure? 658. I agree with you. Then 658 times 6 is what? Times 6 is what? 8 times 6. 8 times 6 is what? 48. Carry for 6 times 5. 30 plus 4.
3,948.
I don't say you should calculate. I look up. I didn't try to calculate. You don't calculate. So stop what you're doing and watch. Let's do it together now. I give you time to do that thing you're doing. It's okay. Let's do it together. Are you sure this one is correct?
Yeah, that is the one we are solving.
Okay. 48, right? 6 times 8 is what? 48. Put 4 here, right? 6 times 5, 30 plus 4, 34. Put 3 here, right? 6 times 6 plus 3, 39. So we have what? 3948 times what? 3 power minus 3 times 8 power what? 2. Is it clear? Is it clear? Are you sure? No. Look at it well. Tell me whether it's correct. This is what? 1, 2, 3. Right? 3. 3. 1, 2, 3, 4, 5, 6. Okay, so here is 6, not 3. Here is what? 6, not 3. Because I have a new number here, 329. You see what I'm saying? If you stop here, it's 1, 2, 3. I want to move every decimal point for it entirely. If you move from here, 1, 2, 3, 4, there should be if you put it here, there should be a decimal point here. Here becomes 4. But if you continue 5, 6, here will be 329 total, which is here. So here should be what? Minus what? 6, not minus 3. Here should be what? Minus 6. Now, this minus 6 law of indices. 3 from minus 6 times 3 square 2 is what? Law of indices. Law of indices.
Minus 12.
Hey, no.
Is it times I mean?
It's times now. 3 from minus 6 times 3 square. 72. What are you doing? 3 from minus 6 times 3 square 2. Law of indices. Mathematics. What do you say?
What's the
answer now?
10 raised to power minus 4.
Good. That's the answer now. Here is 3 square what? Minus 4. So we have what? 3 square what? Minus 4. Times what? 3 9 what? 4 8. Is it clear now? So this here is minus.
You said there will be points.
Now I said you have cleared the point by making it to be. There's no point here again. Now here now becomes 3948 times 3 square minus 4. Bring it back to normal form. Here becomes what? Here is minus 4. Here the movement will start from here. You have 1, 2, 3, 4. There's no point to be here. Here you have what? 0 point what? 3 what? 948. You can approximate it to what? 0.395 what? Gram. It's okay like that. I have punched that calculator and punch the calculator and anyone want to punch. It took me time because people are trying to explain to you how to do this. Sometimes you will not. Sometimes you get it anyway. It's slow. What is slow?
good though. You want to.
It's okay now. What I'm doing is to prepare you because you don't know what you see. What I'm doing is to prepare you because you don't know what you will see. Anything the calculation I'm doing here, I'm not going to use calculator. If you like, spoil yourself with the calculator. It's a business. You will not say that I didn't teach you. If you want to learn it, learn it. If you don't want to learn it, leave it. I'm not competing, but it's better you learn it because you will see yourself in the situation whereby you have no calculator to use, or even that one you are hoping to use in the system disappoint you. Am I competing? That is if they allow you. That is if they do what? Allow you. So it's better to know how to do all this so that you can easily do your calculation without issues. So the answer is what? 0.395 gram.
I almost got it. I just this.
You almost.
I got 394.
Nearly. You can never kill a bird. So it's either you kill it or not. So I can see how we use standard form to solve this thing. Good. That's why you were taught standard form in your secondary school for things like this. It works like magic. You don't do bother yourself too much. You just get the answer. Are we together? So if you are done, put on the second question. Let's solve this second question if you are done. So the second question. Are we good? Put out the second question. Put out the second question. The second question states a current of 5 ampere. A current of 5 ampere is passed through a solution. A current of 5 ampere is passed through a solution of silver nitrate for 30 minutes. Silver nitrate, silver. Formula for no. Okay.
SINO4.
What are you talking about? No. Formula is A G M O.
Silver. Okay. So I see
So that's the formula. Chemical formula, but the name is silver nitrate. A current of 5 ampere is passed through a solution of silver nitrate for 30 minutes. If the mass of silver deposited is 10.8 gram, if the mass of silver deposited is 10.8 gram, what is the electrochemical equivalent of silver? 10.8 gram. What is the electrochemical equivalent of silver? Let me take it again. A current of 5 ampere is passed through a solution of silver nitrate for 30 minutes, full stop. If the mass of silver deposited is 10.8 gram, comma, what is the electrochemical equivalent of silver? What is the electrochemical equivalent of silver? Alright, let me also solve this one. I'll still give you the one you solve here, but let me also solve this one. Just look up. So you see the techniques I'm using to solve with that calculator, because then you're able to solve. I'm going to give you the one. So let me see who will look around and for calculator. Then I'll deal with the person. Just watch what I'm doing. If there's any step I think that you don't understand, feel free to ask me. What do you call it today? Why? Tell me now, what do you call it today? No reason. Tell me now. Yes, now. Alright, let's continue. So, solution. Remember the. Okay, sorry. Remember that M, according to Faraday's first law, right? The mass is equal to electrochemical equivalent times current times what? Time. Remember. Now, we are giving the mass of silver as what? As 10.8 gram, right? Yes. We are not giving a electrical equivalent. That's what we are looking for. So we put question mark. The current is what? 5 ampere. Time is what?
30 minutes.
We move it to what? Seconds, right?
Yes.
300 times what? 60, right? 300 times 60. Sorry. God bless you. 10 times what? 60. Let's leave it like this so that we don't create bogus. Remember, you are not using calculator. So let us not create bogus numbers. Let's leave it as 30 times what? 60. So that it will be easy doing calculation. Is that clear? I say don't create a big number. You are multiplying. You don't know that. You don't give you a cream. If you are solving calculation, don't create big numbers. Like here now, you can leave it as 30 times 60. Instead of doing 1,800, you leave it at this. Now, so we are looking for what? E, right?
Yes.
From the equation. Now, if we make E the subject of the formula here, what will it become?
E is equals to
What?
M over I.
M over what? I following. Are you following? So now let us now substitute the values of M and IT. M is what?
10.8.
10.8 gram, right?
Yes.
Over what?
Over
5 ampere, right? Times 30 times 60. Now, I will perform a magic here now. I remove this decimal point. So it's easy for us to solve. So now let me remove this decimal point by moving it to standard form. If I remove this decimal point now, here, if I move this point now to here, it becomes 108 times 3 to the power what? Minus 1. Is it 1 or minus 1? It's minus 1, right? I have cleared this decimal point now. True of us? Gram. All over what? 5 times what? 30 times what? 60. Solve Can 3 divide 108? Yes. 3 can divide 30. We have 10, right? 10 here, right? 3 divide 10. 3 remainder what? 3 remainder 1. Remember the number base we are working. This is base 10. Hope you know. Are you aware that this is base 10? Normal counting base is base 10, right? So if the remainder is 1, you multiply that remainder by the base you are working on. 1 times 10 is what? 10. You add it to the next figure. If you divide 10, you have 3 remainder 1. You multiply that remainder by the base you are working on. 1 times 10 is what? 10. You add it to the next digits. 10 plus 8 is what? 18. Because we divide again. 18 divided by 3 is what? 6. So here is what? 6. So 108 divided by 3 is what? 36. Is that clear? Good. What else can go? 6 can go. True of us. 6 divided 6 is what? 10. Right? 6 divided by 6 is what? 6. So we have 6 on the top here. We have 10 here. What else can go? Is there any other that can go? Look well.
2 can go.
2 can go. 2 divided 10 is what?
5.
2 divided 6 is what? What else can go? 5 times 5 is what? 25. Times 10 is what? 250. Nothing else can go. Sure?
3 over 250.
I'm coming. I want to be sure that nothing else can go here. Hope nothing else can go here. Right? Good. So, if that is the case, we have 3. Can you see the board? If I stand like this marker is not right here. Oh. Okay. So I feel as if you come here, please come here.
No, I can see.
No, it's I'm talking to her. So we have what? We have 3 here, right? Remember, we have 3 times 3 is 4 hours.
Oh my God,
Over what?
over 250.
No, don't. We have 5 times what? Times what? 5. If this term goes up, if this term now divide what here, so you've got 3 from minus 2. Hope you know. Are you aware? Are you aware that 3 is 4 minus 1 over 10 is what? Remember that here is 1. Remember, any number raised per 1 is that number. So 10 is certain as 3 is per 1. True of us. So we have, if 3 law of indices, 3 minus 1 divided by 10 is 3 minus 2. Do you agree with me? What do you do law of indices in mathematics? So you don't look at me as if you know what I'm saying. I get tired as if I don't know what I'm saying. Okay, can be long. Alright, you swear. So here becomes what? Here becomes what? 3 times 3 is 4 what? Minus 2. Do you agree with me?
Yes.
All over what? 5 times 5. Do you agree with me? Are you sure you agree with me? Are you sure? Are you sure? Now, you see how we use these big numbers to this small thing here. I just need now. If I am to do anything on my own now, one step I'll just get the answer, but I'm trying to break it down for you so you understand the steps on how to go about it. By the time you practice it over time, it will come part of you. You may even get to the lesson that you will see something say, you see it. Without even using your pen, you know what the answer will be. You see how I reduce this big number with this small number. So see watch now and see what I will do here. Just watch now and see what I will do here. This thing can be stated as 3 times 3 is 4 minus 2 times 1 over 5 times 1 over 5. Do you agree with me? Do you agree with me? Are you sure you agree with me? Are you sure? Are you sure? Do you agree with me that this can also be written as 3 times 3 4 minus 2 times 2 times 3 is 4 minus 1 times 2 times 3 is 4 minus 1. Do you agree with me? It shock you? It shock you? Alright, 1 divided by 5 is what? Let's use
how do you get this 2 times?
That's what I want to do here now. I'm trying to show you how this becomes this 1 over 5 becomes this. Look up. Let's use the pattern we used to divide here. Where did you do that division? Here to divide 1 over 5. Let's go. 1 over 5. Let's go. If you divide 1 by 5, is 1 is less than 5, right? It's 0, right? True or false? 0 is less than what? 1. Is it not?
Yes.
Is it not? 1 divided by 5 is 0 remainder what? 1. Because you have put 0 now, you put the decimal point here. Is it clear? So that remainder, this thing is in base 10. That remainder times this times the base we are working on. True or false? 1 times 10 is what? 10. There is nothing here to add it. It's 0. So what we say is what? 0. There is nothing there. So we divide that 10 by 5 is what? 2. 0.2. It shocked you. It shocked you. 1 over 5 is 0.2. True or false? I move these 2 to standard form. See it here. It's simple now. Multiply. 3 times 2 is what? 6. So we have 6.
6 times 2.
Times 3 is 4. It's what? 6. What's going on here? Hope you can see it clearly. So here is 6. Times 3 is 4 what? 3 times 2 is 6. Let's see this one. This is 3 4 minus 2. Times 3 4 minus 1. Times 3 4 minus 1.
So you know multiply all that. 3 times 2 is 6. 6 times 2 12.
Okay, 12. God bless you. This is what? Now, this matter is frustrating us here. We are doing calculation and the board is not clear at all. Yeah? Please, let's use this opportunity to put down something.
No, sir.
All right, let's see if you can conclude this thing. Here is what? Here 3 times 2 is what? 6. Look up, please. Times 2 is what? 12. So we have 12, right? Times 3 4 minus 2 times 3 4 minus 1 is what? 3 4 minus what? Minus what? Minus 3, shade. Then times 3 4 minus 1 is what? Minus 4. So we have 12 times 3 is 4. Minus 4 watts. Remember, this is a chemical equivalent, right? Gram per watt per coulomb. Here is 12. Hey. Here is 12 times 24 watts. Minus so. Are you following this? Are you following? Actually, it's not distracting, confusing you. Minus what?
Minus 4.
Let's move it to ordinary form. We start counting from here, right? 1, right? 2, 3, 4. Here, the decimal point should be here, right? Here is 0, right? 0, 0. So the answer is what? 0.0012 gram per coulomb. 1, 2, 3, 4. You can punch a calculator. You can punch. Punch now and confirm. Had it been as I told you, if I was solving this by myself, I would have solved it and gone my. But because I'm trying to teach you how to use it, you look as if it's taking time. You look as if it's taking time. What do you do? No. You did 12.8 divided by 5 times. As if do it well now. Is that how to even if you said you don't know how to use it, sir. Who can use the letter? You don't know even if you said I also know how to use it. What are you doing?
I don't have to use
It's give out the use. You don't have to use. You better learn this one. I know the song without calculator, please. Before you even type a calculator and confuse yourself in the exam hall.
So this is not scientific.
It doesn't matter. No, the first two devices.
almost they said this one is 80. Then that 10 times 8
This is 10.8. You move it here now.
is 80.
Decimal point will now come here. It becomes 108 times 3 minus 1. It was initially, see it here now. We now move it here. That's why this movement brought up this minus 1. Here it becomes 108 now.
No. After we divide this, we got 3. You
Yes.
said we remained
3 remainder 1.
yes. That
We use the number to multiply the number base we are working on, which is
that's
just 10.
10. So we now need 10 times this 8.
No. 3 divided 3 remainder 1. We multiply, we use that one to multiply the base you are working on. Base 10. 1 times 10 is what? 10. We add the next digit. We add that 10 to the next digit. Next digit here is what? 8. We add 10 plus 8 is what? 18. 18 divided by 3 is what? 6. See, keep dividing. Just press 10.8 divided by 5, divided by 30, divided by 60. That is how to solve. Now we know how to punch the calculator. It's not teaching you.
No, it's not just
Huh? You are really, it's just century. What, okay, you keep that right. As you, me, when I never you say know how to solve like this, I even know how to reduce the more than you. So leave calculator and because calculator was programmed for human what brain. Two of us. It's human that programmed it. So why not learn how to solve this in yourself? Fine. If you are opportunity to use calculator, you can use it. But if not, you can still do what? Solve it and go your way. There are people that once you take calculator away from them, they cannot do any other thing. They will look at you like they can't do anything again. They will start crying. Don't do like that. So the answer is what? 0.0012 gram per watt. It shock you? It shock you? Have you seen how powerful stand up can be? That's this standard for you just believe actually standard for. You see how it move everything, make it so simple. Yeah, let me see. We have barely 7 minutes to go. Let me see if we can solve one more question then. But this one again, I'll give you some time to solve it. Let me see what we can do. Are we together? Yes. Are you sure? Okay. Put down this question.
last one.
No, you solve it here. Let me see whether you all these questions I'll be saying yes, whether you actually following me or whether I'll be busy talking to myself. All right. Calculate Wait. This one may take us to second law. I don't want us to go to second law. This one I want to corner. I will take us to second law. I want you to learn first law very well before we go to second law. Please, just wait. Let me do for question that have to do with first law alone. Okay. All right. Let me give me that. Let me check question from jam past question. Open chemistry and give me. Let me trace question from jam past question. Let's look at chemistry jam question 2 to 3. Let's see what they have here. Question 8 and 8. Let's see whether it has first law. Question 8. This one will take us to STP. All those. Let's go to that 8. No, but don't worry. I know what I'm doing. Don't worry. Let me go to 2022. Question. I want a simple question. 428 that before we go to second law. 428 that no calculation here. 21 12 18 20 12. All right, put down this question. This is 2021 chemistry jam chemistry question 12. 2021 jam chemistry question 12. Put down the question. Are you ready?
Yes.
What mass of aluminium is deposited? What mass of aluminium is deposited when 15 ampere of current is used to electrolyze its molten form for 2 hours 30 minutes? What mass of aluminium is deposited when 15 ampere of current is used to electrolyze its molten form for 2 hours 30 minutes? Option A says 13 gram. Option A says 13 gram. Option B says 17 gram. Option C says 22 gram. Option D says 14 gram. Option D says 14 gram.
Option B 17.
A 13 gram, B 17 gram, C 22 gram, D 14 gram. Are we there?
Yes.
Are we good to go? D, remember, see, jam questions doesn't give you up to 1 minute to open. It's in seconds for one question. So I want to give you 1 minute to solve this question. Fast, start solving it.
You said if multi-point is for 2 hours 30 minutes.
I said, here the question again said, what mass of aluminium is deposited when 15 ampere of current is used to electrolyze its molten form? For 2 hours 30 minutes. Oh yeah, you have one minute to solve this question. 1 minute, no time to waste. Start solving. The question is simple. not a difficult question. Jam cannot give you up 1 minute for a question. And I give you 1 minute.
So like to convert that time 2 hours.
Convert it now. It's simple. And one thing I want to give you about jam is that jam doesn't give you a question that you need capable to solve. The options, that's why I tell you don't need capable. Because capable will put it wrong. Jam options is clear that you don't need a calculator. Once you know the basic mathematical principles, you can solve it without a calculator. It's very simple. Second point, don't create big numbers for yourself. Try to reduce those numbers. Break it down. Don't create big numbers. You see how you wanted us to move over to 1,800. I told you no. Let's leave it at that. So break it down.
Yeah, no, that's okay. I don't want that to come.
Okay, it's okay. Your 1 minute is about to go. One minute going. You don't need it. You don't need it. What is problem? You are giving the currents. You are giving time. So what is remaining? The what?
I'm looking for the mass. No, it's mass you are looking for.
Huh?
There's no electricity.
No electrochemical
She's not here.
Okay. I use finance for constants.
That is 96,000.
I wanted to wait until you enter second law before I can
This is
break
second law
it.
equation.
Okay, no problem. If you know it, if you know it, sorry, no problem. It's my fault. Let me now solve this. Because some may not be able to solve it. But let me now enter that. This will not lead me to. I'm trying to run away from it, but it's dragging me to it. Let me now just give you just a clue on how to use it. Are we together?
Yes, sir.
Maybe in the next class we may not enter second law properly. Is it clear? There's something I didn't mention. I intentionally left it because I want to use second law to explain it. But let me. You need that in here to solve this question. I didn't look at the question properly before selecting. Now let me solve the question, okay? I became the question. Let me see. It says what?
What mass of aluminium is deposited when between arm of the current is used to electrolyze?
So current is what?
Current.
What else? What other parameter was given there? Time is what?
2 hours 30 minutes.
2 hours what? What other parameter? We have two for the mass, right?
Yes.
Basically, Faraday's law, mass is equal to what? True or false?
Yes.
Yes. They gave us this, they gave us time, but they didn't give us what?
Mass.
And they didn't give us what? Is that the issue?
Yes.
Is that the issue? So now there's something I want to, if you know about, remember what happens in the electric cell. For iron, for aluminum to be deposited, but the element there is what? Aluminum, right?
Yes.
Aluminum ion. Remember, it exists as ion inside the electrolytes. See how the aluminum exists. Aluminum is Al with what? 3 plus, right? That means aluminum will gain 3 electrons in order to be deposited as aluminum solid on the wall. cathode. True or false? So if you get what? 3 electrons to be deposited as what? Aluminium what? Solid. True or false?
Yes.
True or false?
Yes.
Good. So that is what happens here. That is what happened here. Now, if 3 mole, this is 3 mole of, hope you know that this means 3 moles of 3 moles of electron. Are you aware? 3 moles of electron will deposit 1 mole of what? Aluminium. Am I communicating?
Yes.
Good. Remember the molar mass. Molar mass is mass of 1 mole. Molar mass is what? Mass of 1 mole. Do you agree with me?
Yes, sir.
3 moles of electron deposit 1 mole. So 3 moles of electron deposit 1 mole of aluminium. So what is the mass of 1 mole of aluminium? What is the mass of 1 mole of aluminium? Well, it's simple. I confuse you now. You don't even know what it is again. First of all, we define molar mass. Madam, what is it? We define molar mass as mass of 1 mole. Okay? So, if 3 moles of electron deposits 1 mole of aluminium, so mass of 1 mole of aluminium is molar mass of aluminium. True or false? Then what is molar mass of aluminium? It's not 27 grams.
Yes.
Ah!
I was trying to.
It's not 27 grams. To be 27 grams, you are lost. Don't worry. After copy notes, okay? 27 what gram. So that means what it means is that 3 moles of electron will deposit what? 27 grams of what? 3 moles of electron need to be what? Need to be what? Taken by aluminum ion to deposit as 27 grams of what? Aluminium. Is it clear? That's the meaning. But Faraday, from the calculation, from Faraday's law, and everything happened, we concluded that we arrive at that one mole of electron is 1 Faraday. So if 1 mole of electron is 1 Faraday, hope you are following the step I'm taking. If 1 mole of electron is 1 Faraday, that means 3 mole of electron is what? 3 watts Faraday. So after 3 Faraday deposit what? Is required 3 Faradays required to deposit 27 grams of what? Aluminium. Are we together?
Yes.
3 Faradays is required to deposit 27 grams of what? Aluminium. So if 3 Faradays are required to deposit 27 grams of aluminium, what does 1 Faraday mean? 1 Faraday is a charge, is a coulomb. 1 Faraday is like 6,500 watts coulomb. Is it clear? 1 Faraday is what? Like 6,500 coulomb. So, if 1 Faraday is like 6,500 coulomb, whenever we say Faraday, we put what? Like 6,500 coulomb. So that means 3 times 96,500 coulomb we deposit what? 27 grams of what? Aluminium. Is it clear?
Yes.
Is it clear? 3 times 96,500 coulomb we deposit 27 grams of what? Aluminium. Now, remember here we are having quantity of electricity here as what? Here is what?
Yes.
Here is IT. Are you lost? Are you lost? Here is what? IT. Hope you can follow. This is logically, please. It's scattered. Hope you can do that as you are putting it down. Just wait. Let me just finish. Here is IT, right? So that means here. The current here is what? Is it ampere? Times what? Time is what? 2 hours. 2 hours, 30 minutes, right? We convert this to what? Seconds. Seconds, right? 2 hours, 30 minutes, you said must say 2 hours for 30 minutes, right? Let's convert 2 hours to.
2 hours plus. Yes.
Let's convert 2 hours to seconds. Is 2 times 60 times what? 60. True or false? True or false? True or false? 2 hours to seconds is what? 2 times 60 times 60 again. True or false? Yes. Because if you want to move 2 hours to minutes, it's 2 times 60. So if you now want to move it to second, you multiply by another 60. True or false? 30 minutes. Or if you like, see, to avoid creating unnecessary, because what are you here now? At least something here, right?
Equation.
No, there's something I think I know that what
Said three electrodes deposit 2.7 mass of.
okay, three deposit what?
27 mass of.
Yeah, for three
3 Faraday.
deposit what? Okay. 1 Friday is this, right? We now get this. Is it clear? Okay, now. See what we do to avoid creating. If I put plus now, it may cause confusion. Let me move this to seconds directly. Then put it here. Okay. So this, let me just move to seconds. This is now saying 2 times what? 60 times what? Plus what? 30 times what? Do you agree with me? Do you agree with me? Yes. Let's solve this thing well, because here now we can't break it here if it cause confusion. So let's solve this one separately. Then put it inside here. Okay. So let's go. 60 times 60 is 3,600. Do you agree with me? Do you agree with me? 60 times 60 is 3,000 what?
600.
Times 2 is what?
7,200.
Good. No more than record. I like that. 7-2. Alright, here is what? 7-2. Let's keep it somewhere. 30 times 60 is what? 1 what? 1 8.
1,800.
Plus 7-2 is what? 9,000. So here is 9,000 what?
Seconds.
9,000 what? Seconds. Do you agree with me? So we bring it here. The time is now what? 9,000 what? Seconds. Is it clear? So this is the quantity of electricity. This thing here is quantity of what? Electricity that deposited what? 27 grams. So we want to check the mass of aluminium that will be deposited by this quantity of what? Electricity. So if 3 times 9,600 deposited 27 grams, 15 times 9,000 coal will deposit what? X. Is it clear? You don't know what it will be what? Deposit. So let's find out X and get our answer. So if you make S a solid the formula, please X is now equal to what? Times what? Times what? 27 grams. Over what?
3 times 96,500.
3 times 96,000 what? 500. Are we together? So what can go?
3.
3 can go here. True or false? Yes, 3 can go. If 3 goes, if 3 the divided between is what?
5.
5 can dismantle here. True or false? 5 can go. Let's go. 5 divided 9. 5 divided 9 is what? 1. 1 remember what? 4 times the base you are working on.
Yeah, guys, 40.
40 plus 6 is what?
46.
46 divided by 5 is what?
9. 9 remember 1.
9 remember what? 1, right? 1 times 10. 1 times 10 plus 5. 15 divided by what again? 5 is what?
3.
3. This one that's what? Just 0 what? 0. You have dismantled this now. So what can go again? Look up. What do you think? What do you think can go? 5 years has gone. What is remaining here? These 2 zero can work, can clear this two of us. Now let's go. What else can go? Let's try 7. No. Let's try 3. And see. Let's try 3. Can I go share? You can go, right? So what else can go? Are you sure? This is 3 6 7 2 18 1 8 8,000 9,000. Okay. Here is correct. Here is correct. Here is 96,500. And here is 5 here. Here is 1 4 6 46 9 1 15 3 0 0. This will take care of this. You say what?
That's 19,700 divided by 190.
No, I'm coming. The option, you know, as you're solving, be careful about what you're solving. Have you seen it now? So that's why I'm questioning something here. Okay, let's just divide now and see what it will give us. Okay. All right. So here, what here 9 is remaining here. 27 is remaining here, right? Okay. Bring that question again. Sorry.
What mass of aluminium is deposited when 15
for 2 hours and 30 minutes. Shame?
yes.
Hold this in for me. Just fold this that side. Let me check something. I'm coming.
The answer is 8
Huh?
That's it. The answer is 30.
I'm coming.
Yes.
I'm coming. Calm down. I'm coming. Just calm down. I want to confirm something. I'm coming. Before I can continue, I'm coming. Okay, you use like or what? I'm punch one here. I'm coming. Just calm down. Hold this in. Hold this in. If here is 5, if 5 divided this is this. How is it 13? Without the decimal points?
We have approximates.
I'm coming. Alright, so let's go. So here is that means them have changed their pattern. That means they are now projecting calculator. But it's okay. Let's divide this calculator, please. Let me not solve because I wanted to be sure what I wasn't seeing this in covenant as a whole number. I wanted to confirm to show that there's no error in the question. But since there's no error in the question, let's divide it. So here, look up please, look up. So let us now multiply out and divide strengths and get our answer. 90 times 27 is what? Times what? 27. 7 times 0. 7 times 9.
7 times 9. 63.
63, right?
Yes.
Are you sure? Are you sure?
7 times
3 times 1, 21. 21 times 3 is 3. Good, you're correct, 63. 2 times 0. 2 times 0 is what? 0. 2 times 9 is what?
83.
We have 0, 3, 14, right?
Yes.
So 2,430, right? 2,430 divided by what? 193. So let's cancel out. Since there's no error in the question, let's not cancel out. Let's go. How many 93 can we find inside 243? 1. Calm down. No. How many 93? How many 193? Sorry. How many 193 can we find inside 243? How many? How many 193? How many 93 can we find inside as a real number? 243. It's 1 now. It's 1. Two of us. Then so that means if we divide 243 by 193, we have 1, right? 1, remember, we subtract this 193 from 243.
Okay.
And to do it, what's that? 243 minus 193 is what? It's not 50. It's 50, right? Hey, it's 50, right? Good. That remainder, right? We multiply that remainder by the base we are working on. 50 times 10 is what? 500, right? Here is 0. So 500 plus 0 is what? 500. We keep dividing. 500 divided by 193 is what? So how many 193 can we find inside 500? That's the question first. As a whole number. How many 193 can we find inside 500 as a whole number? Is it 2? Because 193 times 2 is what? 386, right? So it's 2 whole number, right? Because the very one cannot be enough, right? So it's 2. So it's 2. 2 remember what? I have subtract that 386, right? From 500. What is the remainder? No. 500 minus 386 is 24. What are you saying? 124. It's 124, right? It's 124, right? 124 times the base we are working on is what? Base 10, right? 124 times 10 is what? 1,240, right? Right? We keep dividing. 1,240. Remember, we have exhausted this. Hope you know. Any other thing that's happening now, we have exhausted this original number here. So whatever that's remaining will be in fraction. Are you aware? So after these two, the decimal point will do what? Come. Are you aware? If you have 24 divided by 10. Once you are done, anything you are dividing now outside this last digit, the decimal point will come in. So because we have exhausted this, bring it. Thank you. Are you following what I'm saying? Because you have exhausted here. Well, that 1,000, because the first when we did, no number ended at a point we added and then 500. That time we divided 500 by 193 and got 2 number. That one that is remaining. That remember we introduce decimal points here. Well, there is nothing else to add it to here again, and we will keep what dividing. So
you have to find the remainder.
Yes, that remainder is 124. You multiply it by the base. which is 10. It becomes 10240. But there's nothing else to add here. It has ended. That means we have to introduce what? Decimal point and keep dividing. So if now 1240 divided by 193, how many 193 can we find inside 1240? How many 193 can we find inside? Is it up to 5 or more than 5?
Because 500 is 2, that means that one.
No, it's more than 5. Yeah, yes. It should be let 193 alone times 2 is
So 193 times 5.
wait. Look at the person we are working to see if we can help ourselves, because it's project can help us. 193 times 5 is what? Let's test it. Times what? 5 times 3 is what? 5 times 9 is what? Plus 1. 5 times 1 is what?
5.
Plus 1.
Plus 4.
Plus 4 is more than.
Like 1,060 minus.
We are looking at 1,424. In fact, if you went up to, let 190 times 7 is what? 9 times 7 times 3 is what? 21, right? You put 2. 7 times 9 is what? 63, right? 63, right?
Yes, sir.
Plus 2 is what?
Plus 65.
65. Do 6 here. 7 times 1 is what?
7.
Times plus 6 is what? 13.
More than.
So 6. We have 6 whole 6 as a whole number. 7 is a bit above it. 5 is below. So 6. So if you do 193 times 6, it will give you what I'm looking for. 3 times 6 is what? 8. 18. 6 times 9 is what? 3 times 9 is 54. Is what?
54.
It's 4, right?
Yes,
Plus 1. 5 will be here, right? 6 times 1 is what? 6, right? Plus 5. So we have 158. 1,158. So inside 1,240, we have 6. We have 193 into 6 as a whole number. So 6 should come here. Are you there? 6 should do what? Come here. What we remember? We subtract this 1,158 from 1,240. I do it. 1,240 minus 11 what? 58. Let's go. Right? 10 minus 8 is what? 2. Remember, 3 is many here, right? Take 1 here. 13 minus 8. 5 is what? 8. What is many here? Minus 1. Nothing. It's 82. It's 82, right? So we have 12.6. The remainder is what? 82. 82, right? 82. The base we are working on is what? 10, right? 82 times 10 is what? 820. Right? There are nothing to add again. You keep dividing. 820 divided by 193. Remember, we have already got to 193 into 5 here to be what? 958. True of us. So here should be 4. Do you agree with me? If 5 gives us 968, that means 4 times 193 should be around. It should be less than this, and it should be around that what 820, right? So let's now do. Is there a place we did times 4 here? We did not do times 4, but we did times 2 and not 386. Multiply it again by 2. 386 times 2 is what? 92. 386 times 4 times 2 is 796. 386. Okay, 772. 772. Good. I am doing 820 minus 772. 820 minus 772. 820 minus what? 772 is what? This is 8. One is burning here. Carry one put here. 11. 11, this is 4. 48. 48, right? 48. Multiply them by the remainder. Come back. Let me bring it up to 3 times, then we stop. 48 times 10 is what? 480. How many 193 can we find inside 480? Is it 2? It's 2, right? It's 2. We can stop here. Now, point like I get you get something like this before you approximate 12.642. Plus other numbers. Punch it out.
All I got was 12.59.
Is that what you got? That means the information. 12 point what?
That not like 59.
590. But you got the point I'm trying to make.
If you have approximated 6
But just know that. Do you know why we are doing this? Nothing prevents you from telling to punch your calculator and you get the answer. But I want to introduce you to something else so that in case you don't know where you see yourself tomorrow.
So this method you did now, just like that method is not like
Yes. But I didn't want to draw this now. I'm telling the principle. You do all this without knowing what they're doing. Okay, now let me ask the question here. That's do you know? Let us look up. When we did 240 minus this, we got to this place. We took one from here, right?
Yeah.
And if you take one from here, what happens? Continue. Take one from 4. What happens?
Minus.
So what you have to you add what here? Why we add 10 there? You took one from here. So what do you add 10? It's what?
Because 0 cannot subtract it.
Yes, you took one from here.
Yeah.
So why do you call it 10? They'll tell you took one and call it 10. Why? You multiply by the base you are working with. It's not you multiply by the base you are working with. So that one you multiply by 10, it becomes what? 10. And if you are working in base 4, you multiply by the base you are working with by 4 before you add. Is it clear? This is not part of this topic, but I just want to use the opportunity to tell us about. Can't you see? I spent almost 30 minutes trying to explain this, but it's okay. I am opening your eyes in some things you didn't know about. Is it clear? So just we'll stop here for today. Now in our next class, we'll continue from where we stop. Is it clear? Any question? Assignment. Okay.
This number 30.
Is that one you choose?
It's the same topic.
Okay. Do this number part 8. Don't look at this book. Do this number part 8. Copy it. That should be number. No, it's not here. It's in the. It's in 2021 question. Do that number 8. Is it clear? After copy it from the past question. Any question? You're welcome. Please after try to see what they did. We done so far and copy it. Okay. All right. Thank you very much for your attention. God bless you. See you next time.